Welcome to Ask and Learn.
All right, guys, for question number 62 in Chapter 5 of Chemistry Essential Science, we're going to be using Hess's law to figure out how to calculate the change in enthalpy from converting product A into product C. So Hess's law can be summed up basically like this. Delta H of reaction is equal to delta H of products minus delta H of reactants. So basically, it doesn't matter or what direction you go from point A to point C, so long as you're going from point A to point C, because that change in energy, regardless of how you're getting there, is always going to be the same. So we're going from A to B and then B to C. So the way to figure this out is to add our equations together, which we're going to have A on the left side, the B's cancel out, and then we'll be producing C. And then the delta H is going to be delta H is going to be the sum of the delta H's. 30 plus 60 is equal to 90 kilojoules. So now we're going to look at an enthalpy diagram to better understand how this works. So so we're dealing with endothermic reactions. So we're going to be going from a low energy level to a high energy level. And over the course of the reaction, so you can see how the energy levels change over the course of the reaction. We're going from A, and we can convert to B, and there's going to be a net increase of 30 kilojoules in the energy state when doing this A to B transition. When going from B to C, we're going to further increase H by 60 kilojoules. Now, remember what I said. It doesn't matter what direction you go from A to reach the C. It just matters that you're going from A to C. So that is always going to be constant. So it is going to be the sum of 30 kilojoules and 60 kilojoules, which is 90 kilojoules. So that's very important to remember. That regardless of what pathway you're taking, as long as you're converting A to C, your change in enthalpy will always be the same no matter what.